Zach? Am I on?
Yep.
All right, awesome. Okay, I'm Drew Marchetti, President of Life Safety Service. Here today to go over this inverter. We're at Foisey Innovation, WPI. This is here to back up your lighting when the power fails, basically. So when the AC input of this unit disappears, it senses that, starts and runs, and continues to put a sine wave out to the load that's connected to it. Okay? As far as the lighting fixtures that are part of the output of this unit, they'll never know the difference. Okay? It's required to run for a minimum of 90 minutes to get people out safely in an emergency power outage or other emergency. Okay, so actually the unit manufactures an AC sine wave via DC coming from the batteries. Okay, so that's what this thing basically does. You see on top, control electronics, bottom are the batteries, your supervisory controls, of course, on the front. Okay, we'll go over those before this video is over. So, some numbers for you. You have 12 batteries in here, all in series. 12 volts a piece, obviously. So 144 volts is your DC nominal voltage. It'll float about 163. Okay, I don't know if you remember this, but for the sake of the video, that's what this thing is supposed to do. Okay, on the front, it'll say 99.9% of the time, give you the date and the time. It'll say line present, battery charging, system ready, no alarms. That's what it'll say all the time. Okay, if there's an interruption in utility power, which causes it to start, it'll go into utility failure, just telling you that, you know, I'm missing my AC input. It'll start and run. You'll hear it audibly with fans running. Okay, you'll know it's in emergency mode. Okay, we can do that now. I'm going to fool it into thinking there's an emergency by killing the AC input breaker right here. Okay, so it starts, runs on battery. You hear the fan start. You see the utility alarm. To shut it up, just hit escape. It may alarm again to remind you, hey, I still don't have AC input. Just hit the escape key, away you go, okay? Again, the load never knew the difference. The lights are still running fat and happy. They have AC power like before. They don't know whether it's coming from this or the telephone pole in the street, nor do they care, okay? As far as working this, I'm gonna escape. There's my, now it says line not present, battery power, system not ready. Well, it is ready, it's running. It's running on emergency power, okay? If I hit enter, I'm gonna go to meter and see the two arrows on the side coincide with these two arrows. You can go to test log, event log, alarms, user setup, factory setup, status, system info, test mode, meter. Meter is what we're gonna generally want. So the AC input voltage, of course, is off because there's an emergency situation. I'm gonna slide it to the right. My output voltage is 282.7, which is manufacturing right now via the DC from the batteries, okay? My output current is 10.3 amps. My battery voltage is 147. I started at 163, which is where my float was. So it's drifting down now toward its 144 volt DC nominal voltage. It shouldn't hit that nominal voltage though, at any time, unless there's a longer than a 90-minute power failure. So within that 90-minute window, it shouldn't go below nominal 144. If it does, that's a signal to me as your service guy that the batteries are getting a little tired. But that shouldn't happen until, you know, 2022 or 2023, okay? Battery current, so the amount of oomph coming from here to go into here to drive that load is requiring about 23 amps of DC current to make that work. Internal temp, inverter minutes, system days, a bunch of stuff we don't care about. Okay, so it's running now on emergency. You can tell by the fan, you can hear the fan. Okay, to go back to standby, I'll re-energize AC input. Right now it's resyncing with the sine wave from the street. Okay, when it does, you'll hear some clicks, the fan will go down, battery charger will automatically click on. Sometimes the fan runs a little longer to keep the parts cool for the charger as well. There's my input voltage, 286.1, which is restored obviously. Back online, battery's recharging. We go to escape, line present, battery charging, system ready, no alarms. Gives you the date and the time, okay? The system also was installed with an external bypass switch, okay? So for any reason the system goes down, or if there's a problem with the circuit board or something, and the AC output disappears because there's a malfunction in here, you can throw this to the bypass position and restore your AC output to your load because it's just a pass-through at that point. So you got a gazinta and a gazada only when that's in the bypass position, okay? One caveat with these switches, very important, if the system is running on battery, never touch the bypass switch, okay? Because you've got AC input coming from the street and you're going to bypass when you're actually manufacturing a sine wave in here as well. You don't want that. The way the two AC sources are going to be fighting each other, and that's a bad thing. So only flop over to bypass when the system is not running on emergency power. Okay? And how do you sense that? Just be sure that you've got AC input by going to your meter and I got AC input, yes. Or the fan will be off. Right now the fan's running to charge the batteries. Generally it's going to be silent. Then it's okay to go to bypass. Okay? On any piece of equipment when you go from manual to bypass. That's a good thing to remember. Okay, inside here, you've got your access to your input breaker here and your single output breaker which feeds an external distribution panel somewhere here, someplace. Okay, so there's only 2 breakers in all of these inverters in this building. Why was it that way? I don't know. They could have had a distribution right here. Well, I'm not sure, but so in these systems, there's an AC input breaker, AC output breaker, single AC output breaker that feeds an external bypass panel somewhere. If you're ever a first responder to a problem with these, okay, the fan turns off, batteries are almost fully recharged. This is how it'll sound most of the time. Fan off, same nomenclature through the display. It's pretty safe to throw it in the bypass right now if you elected to do that. But say you're a first responder, I got a problem with this unit. Go check it out, Ted, for example, right? First thing you want to do is come in, use your nose. If there's a sulfur, egg, rotten egg kind of smell, red flag. That means the batteries are probably being overcharged or one of the cells in one of the batteries is shorting. That could cause a problem. That's a bad thing. So the first thing you want to do is stop the current from the charger going into the bank of faulty batteries. Okay, so you can do that in a couple of ways. Main DC fuse is right here. Okay, see that fuse right there? And there's a tie wrap. You can just yank that son of a gun right out, okay? That'll break electrical and mechanical connection to the charger, from the charger to the batteries below, okay? So that's what you want to do. Remember, if you're in a little bit of a panic mode and you want to shut the thing down, you don't want to kill the AC input because then it'll try to start and run. You don't want to do that, okay? So you want to kill the DC first and then the AC, okay? Inside the book right here, if you ever need to shut it down and start it up, there is a procedure to do that, like any other piece of equipment. I'm not going to go through it now. There's a book in there that tells you. It's not hard, but it just is a procedure that needs to be followed, especially on startup, okay? So just know that. But in an emergency, you want to shut it down, you can pull the DC fuse, okay, which disconnects the DC, and then over here there's something called an installation switch, silver toggle. Throw that to the opposition. That just kills any AC input to the inverter control card right here. Won't allow it to start, won't allow it to run, won't allow it to charge. So in that case, there's no AC going to this, disabling this, and you've disconnected your batteries from your stuff up here. It'll be dead. It'll be shut down. Okay? My sticker's on the front. If you need to call me, my number's right there. Okay? But it should run trouble-free for at least 5 years. When the power is restored after an emergency situation is over, it should restart automatically. Doesn't need any human input at all, assuming it's operating correctly. Only time it won't restart is if the batteries are in such poor condition that the battery DC after a long power failure won't recover over a certain point. Then it won't restart. Then it will call to your attention that, hey, I need some service here. But generally, with a good set of batteries, it'll restart automatically, start the recharge process for the next power outage. No fuss, no muss. So there really isn't a maintenance regimen. If you're in the room, in the area, you know, stick your face in, use your nose, use your eyes. Otherwise, it's just, you know, doing annual inspections per code, keeping it clean, take a, you know, dust, keep it clean, but otherwise, it should be fine. Now, right on top, you know, no storage. I don't want anybody spilling anything in there, which obviously, you know, Dawn dishwashing liquid and that do not mix. So I'll put that on top once these guys are out. You know, we should keep that top clean and it's not a shelf, basically. One last thing that I will mention, if you're ever in here working around, DC is a crazy thing. It's very dangerous. And on these particular units, I'm going to put my DC meter on here, if you can see it or not, but basically ground, battery negative, and cabinet are all tied together. Okay, so if I put my meter on the positive, it's on DC right now, put my meter on positive and go to the cabinet right here, you'll see I have 163.5 volts DC between here and here, okay, between positive and any point of the cabinet, anywhere, okay? Which is right now it's floating at about 163 volts, okay? So if I had a positive live DC cable in my hand and I did this, direct short, kaboom. You don't want that, okay? Just know that. So shelf, cabinet, this are all battery negative, okay? Just to be, I don't think you'll have to, you'll call me before you do that, but just know that on these Meyer systems, there is DC potential on the cabinet, okay? Again, I don't think you'll use it, but you want to plant that seed in your brain, okay? Any other questions that you have for me?
The batteries are sealed and require no service.
Correct.
Are they able to be replaced by WPI?
They could be, but based on what I just said, I wouldn't recommend it. It's just too dangerous.
Who would perform that when we did?
I am as Life Safety Service, Myers' authorized service center. Okay, so if there was a problem here, they didn't read my sticker, they'd call the factory would call me anyway, as their local guy. Okay, again, you could, it's your unit, you can do whatever you want with it, but because most guys are unfamiliar with the dynamics and the dangers of DC versus AC, I wouldn't recommend it.
What's the warranty on it?
Warranty, because I'm here starting it up, is 2 years full on anything above this shelf. Okay, the batteries have their own warranty from the battery manufacturer, 1 year full with a pro rata warranty after that.
Okay, so we have one branch circuit with 277 volts on that joint.
Well, you have, correct, this is 277 in and out, 5 kVA, 5,000 watts.
And you're saying that
There's an external distribution panel around here somewhere. I don't know where it is, but
that's feeding?
that would be feeding, correct, correct. Yeah.
Is this the branch circuits right here?
This is the input. That's your branch output right there. So this wire right here is going out through the bypass, up through there. Could be this, could be that panel right there. So whatever in.
It's only one phase, say 8 phase.
This is a single phase system, not 3 phase,
Right,
single
yeah,
phase only,
understand.
yes. So let's take a quick peek in here. Yeah, none of the circuits are labeled right here again. So if this were its distribution panel, you know, this would probably be, you know, first floor stairwell. This would be first floor, whatever, right?
There's a lot of branches.
Right. Again, that could have been done from here. I don't know why it was externally done, I don't know, but.
And we don't operate that under load.
Correct, under emergency power. When it's running on battery in E mode or inverter mode, leave that alone, okay? Basically, that's here only to take the system out of service. So when that's in bypass, you got a gazinta and a gazada, everything else is eliminated. But you're able to get your load lit, your lamps on, temporarily while this thing's out of service, instead of having dark corridors and dark stairwells and having to come in here and physically join these two. That switch does it for you. Okay? No questions? No Shama questions? Okay, that's a wrap.
Thanks, everybody.
Thank you.